1.3, Cartesian Coordinate System. Fancy words, kind of. Anyway, it means graphing, right? The Cartesian Coordinate System is our XY ordered plane that you have seen before. And actually, let me draw the picture right here, since I don't have space on the next slide. So the Cartesian coordinate plane has an x and a y axis. And just make sure that everybody remembers where everything is. This is my x-axis. This one's my y-axis. This is the positive side of the x-axis, and this is the negative side. On the top is the positive of the y-axis, and this is the negative side. And anytime I'm looking at a particular point somewhere, it has an ordered pair. The ordered pair will list x first, and it will list y second. Okay, everybody remember some of those details? I hope so. So as we're taking a look at some different components in this, there's two formulas first that we're going to start with. We're going to start with the distance formula and the midpoint formula. So in both of these formulas, we're talking about two ordered pairs that we're finding either the distance between, right, length, or we're finding the midpoint of, the halfway location. All right, so distance formula is d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. And the cool thing about the distance formula is that because we're squaring those individual subtraction pieces, you can actually subtract in either order. So if I did 5 minus 2 and I square it, or I do 2 minus 5 and I square it, I get the same thing. So there's some sort of forgiveness kind of built into the formula. We don't have to be quite so careful to make sure that things are actually really in the right exact spot like that, which is kind of nice. We don't have quite as much freedom in the midpoint formula. The midpoint formula finds the location that's halfway between 2 points. In this formula, we have to add together our x values, but since it's addition, again, it could be in any order. And we would divide by 2. And then we have to add together our y values, again in either order, and we can divide by 2. The not freedom that we have in both cases is that we can't mix the x and y's together. I can't take an x component of one and the y component of the other. That won't work. So you do have to make sure you're grouping the x's together and grouping the y's together. And we're going to do a couple of examples now of the distance formula and the midpoint formula for a couple of sets of ordered pairs. Make sure everybody has their writing done, I'm sorry. So our first set of ordered pairs, the look at the directions, of course, says find the distance between them, and then it says find the midpoint. So we're doing both of those formulas, distance, midpoint. And our two ordered pairs are -3, -2, and 9, 3. So first we'll start with distance, just because it's listed first. So we're going to put the square root on, and the square root will stay on the problem until we actually deal with it. Don't disappear the square root earlier and just do a little bit of side work and then come back to it. It's on every single step. And then I need to take the two ordered pairs, x values, and subtract them. So I'll just go in order. This is -3 minus 9. Those are my x values squared. Plus, it is addition between them. And then it's -2 minus 3. Again, squared. So what's -3 minus 9? -12, right? And what is -12 squared? First of all, is it positive or negative?
144.
Positive, and it's 144, yeah. So -12, and then I square it, the negatives are eliminated. And that happens on every single part of this distance formula, right? I don't end up with negatives being added together at the end. The other one, what's -2 minus 3?
-5.
-5. And what's -5 squared? 25. So plus 25. All right, 144 plus 25 is what?
169.
169. Do you guys see how my square root's on every single step? Yours should be as well. And what is the square root of 169? 13. It's a beautiful one, right? Absolutely fantastic. My midpoint. So for my midpoint, I'm going to add the two x values together. So in the distance formula, I subtracted them. In the midpoint formula, I add them. So I have negative 3 plus 9 over 2. And then for my y values, I have negative 2 plus 3 over 2. Okay, what's negative 3 plus 9? 6. 6 divided by 2 is 3. Negative 2 plus 3. 1. Yeah, it's 1. And then 1 divided by 2 would be 1/2. Or you can write it as a decimal if you wish. So here's my midpoint. And here's my distance. You guys remember doing that? Yeah? Awesome. So we don't necessarily have to have a whole number of values that work out beautifully. We can also end up having, that's the one, those are just switched, it's no problem. We can also end up having decimals or fractions or any kind of values, truly. So I thought we'd do an example with some decimals. Same thing as before. Distance formula, midpoint formula. So my distance formula, I take my two x values and I subtract. So I have negative 2.3 and I have 4.7, so minus 4.7 squared. And then it's addition. And we'll do the same thing with the y value. So I have 1.5. And I have negative 7.5. So I have minus a negative 7.5. So what's going to happen when I minus a negative? Inside here. Yeah, these two negatives are going to end up making an addition. So I'm going to get a positive right there. All right, so let's take a look. Grab your calculator if you would like it. This one. I have negative 2.3 minus 4.7. What is that?
Negative 7.
It's negative 7. So what is negative 7 quantity squared? 49. So still got a square root. I now have a 49. I have 1.5 plus 7.5, which would be 9. And then 9 squared is 81. So this one ended up working out to being some pretty nice values as I started working, right? 49 plus 81. What is that? What is it? 130. 130. So one of two things can happen at this point. One option is that you may be asked to find a decimal approximation. So let's do that first because your calculator will help you. So if you plug in square root 130 to your calculator, what decimal approximation do we get? 11.4. And it'll tell you inside of My Math Lab how many decimals it wants. Okay? So one possibility is it asks for a decimal. The other possibility is that it wants you to simplify the radical itself. And we talked about that back in chapter P, so let's take a look at what that would be. So if I factor this, this is 10 times 13. 13 is prime. 10 is 2 times 5. But what you'll notice is that there are no components, the 2, the 5, the 13, that actually occur twice, right? So I can't take anything out of the radical, which means that square root 130 is actually as simple as it gets in radical form. All right? You factor to see if there's anything that comes out. If I had two 2's, I'd bring a 2 out from underneath the radical, and it would no longer be underneath it. But this one doesn't have any. All right, let's do the same thing then with our midpoint formula from before. So I'm going to add the values together. So I have negative 2.3 plus 4.7 divided by 2. And I have 1.5 plus my negative 7.5 divided by 2. So negative 2.3 plus 4.7, what is that? Just the addition on top, what do I get? 2.4. I have 2.4. And what is 2.4 divided by 2? 1.2, right. So the x coordinate here is 1.2. All right, over here I have 1.5 and negative 7.5. What does that give me? Negative 6, right? And it's negative because the 7 is the bigger value and it's negative. So negative 6, and negative 6 divided by 2 is negative 3. Yes, indeed. So there's my midpoint. This is the decimal approximation if I was asked for that too. So those are all the three potential answers I would have for this problem. All right, the next thing we're going to look at graphing-wise is what happens when we have circles. So this is a standard form of a circle with the center HK and the radius R. And it looks like this. X minus h squared plus y minus k squared equals r squared. Again, that should look familiar. Maybe you haven't done it in a really long time, but it still should look familiar. So we're going to use this formula, and we're going to be able to take those pieces of information, namely the center of a circle and the radius of the circle, and we should be able to create the equation of the circle. The h, the k, and the r are the pieces that we would need to know. So take a sec, and I'd like for you to create this circle. Write down what you think it is, and then turn to a neighbor and make sure you guys have the same thing. And if not, talk about which one maybe has an error in it. Okay, check in with somebody nearby you. See if you have the same thing or if there's an adjustment that you or he, she, whoever's beside you might need to make. Drew, just turn around and ask them behind them and see what they've got. And Wesley, you can do the same thing. If you'll just check with people behind you and see if things are matching up. Not sure? Okay. Okay, so somebody tell me what equation you ended up with when you wrote this down, and then we'll talk about maybe why it works or doesn't work if we end up with an error. It's okay.
Plus 1 squared plus y plus 6 squared equals 1/9.
Okay, is that what we have? Okay, I see some nodding, that's good. All right, so why is it x plus 1? Maggie, you gave it, so now you're on the spot. Instead of say x minus 1. Why did that happen?
Minus a negative, which is a positive.
Right, so this is minus h in the problem, but my h value itself is negative, so I've got minus a negative 1, I've got a positive 1 then. And the same thing happens with the 6, right? Yeah. And then my radius is 1/3, so what happened to get 1/9 over here?
1 times 1 is 1, 3 times 3 is 9.
Yeah, so 1 times 1 in the numerator is 1, and 3 times 3 in the denominator is 9. So we get this for my radius of my circle, or for the square of the radius of the circle, 1/9. Okay, the next two examples that I have are actually taking the equation itself and then going the other direction. So we're going to take an equation and we're going to figure out what was the center and the radius, and then we're also going to graph them. Okay, so taking a look at this one, I have x squared plus y squared equals 16. I need to know the center and the radius. So any ideas on the center? Yeah, so this one does not have anything next to the x before I square it, so there's an understood 0. And the same thing for y. So my center is 0, 0. Okay, so somebody else tell me, what do you think the radius is? It's not 16, but you're close. It's 4. Yeah, because 4 squared would be the 16. So you're looking at the right value if you're looking at the 16 to make that decision. And then over here on our graph, we're going to plot the center. And then in order to graph it, we're just going to go 4 out in each direction on the x-axis and 4 up and down in each direction on the y-axis. And we're going to do our best to try and make it connect in something that looks circular. Okay, so those are my 4. I'm going to connect the corners. They're corners right now because I haven't connected anything. I'm going to try to do it in a fashion that looks circular. And I get to cheat because I have a circle tool. I know, it's not fair. So it looks something like that. It's fairly believable. Yeah? Your circle's not going to look great. It's okay, mine never. That's why I'm cheating. I don't draw very well. Okay, B. B looks a little bit funny. What is it wrong, not wrong with, but what is funny looking about B? Yeah, you're right, Doran. The y minus 3 is sort of on the wrong side of the standard form anyway, right? So the first thing that I would do is I would shift it. Okay, if you need to move things around so that it looks more correct, we can do that. And it is addition because it was subtraction on the other side. And I can move the whole stinking thing on over there. And then it's in the form that looks like the standard form. And so it's easier to identify all my pieces. All right, so what's my center? Okay, so is it 3 or is it negative 3? It's actually positive 3. And that's one of the easy mistakes to make because you want to remember that the formula itself has a negative in it. Right? So if there is a negative 3 right here, the k value is actually positive 3. It's the opposite sign. What's my radius? What is it? 3. It is. It's a radius of 3. All right, so anytime the center is not 0, 0, graphing it's a little bit trickier. So my center this time is actually 0, 3. So I'm going to go 1, 2, 3. There's my center. And I'm going to go 3 in each direction, up, down, left, and right from where I'm at. So if I go down, I'm actually going to be back on the origin. If I go up, I'm right here. And then I need to go left and right, but I'm going to give myself a reference point here below. But I go left and right from the center. So those 4 yellow points that are surrounding the one in the middle are the 4 that I'm trying to connect. We'll see how well I can do. Something like that. There's some really cool graphing utilities inside of my math lab as you're working on these problems. So it will give you the ability to do kind of what I just did on the board with stretching out circles and so forth. All right, so before Friday, you have section 1.2 homework due, and I would start 1.3. We're pretty close to being done with 1.3, and these work faster than word problems, so I suspect we will finish 1.3 and 1.4, and you'll have both to do over the weekend. Our quiz, like Yana mentioned, will be pushed back then to Monday because I think the quiz is 1.1 through 1.3. Does that sound right? Or 1.4? I can't even remember now. 1.1 to 1.3. So that will be pushed back to Monday. Okay? Have a good week, guys.